All right, so yesterday you did just a quick little review over exponents, which is what you took a quiz over right before break. Today we are going to start talking about exponential functions. So you're actually going to see like exponential equations. This is going to be a 3-day process here. You're going to need Desmos. So I have my phone handy because that's where I use my Desmos from. But you're going to need to be, you're going to have to fill in tables and stuff, and Desmos is what's going to help you with that. So have that available. For those who want these note packets, and I think these note packets this unit are going to be very helpful because even though you're not technically going to have to graph, you're going to want to know what these graphs look like. So you're going to either want to create your own graphs or, like I said, stop in. And I have extra note packets for you. So if you need a note packet, come see me. So today we're just going to talk about the exponential graphs and some of their characteristics. So in an exponential graph, there are two new things. Not really, this isn't new, but there is a new thing called an asymptote that we've got to talk about. But the first thing that we're going to chat about is the Y-intercept. And we've done Y-intercepts before with the linear equations. What the Y-intercept is, it is where the graph crosses the Y-axis. So, and where the graph crosses the Y-axis is a point. So your Y-intercept cannot be a number. It has to be an actual point, an XY coordinate. And we're going to do a couple of these to help you today, just to kind of refresh your memory on that. The next thing is an asymptote. So this is new for you. And what an asymptote is, we are going to only deal with horizontal asymptotes. Horizontal asymptotes, horizontal is left and right, okay? Just so in case you didn't know. So what you're going to have to figure out today is what is the line that goes left and right that your graph gets really close to, but it never actually touches. That's what an asymptote is. It's a line that your graph gets really close to, but never touches. And your equations for a horizontal asymptote will always be y equals and then some number. So Y-intercept is an XY point. Horizontal asymptote is going to be y equals something. And then we're still going to be doing domain and range as well. So exponential functions that you are going to see today are going to look like this. Y equals some value a, parentheses b, to the x. Sometimes they don't have an a, and that's okay. That means that the a is 1. This a, which that we'll be chatting more about writing these equations tomorrow, but this value a is going to be your initial value. It's the value it's the y value when x equals 0. We're going to definitely talk more about that when you actually have to write them. This value b is going to tell you whether or not your graph is going to be growing or decaying. It's the growth or decay factor. If the b value is greater than 1, that means that you have growth. That means that your graph will go like up. From left to right, it'll go up. If your b is less than 1, that means that you have decay. And from left to right, your graph is going to go down. So it's either going to go up or down. So you're going to see these are curved, so they are a little bit different than what we're used to. Today, though, you're not going to have to really worry too much about writing or knowing what the exponential function is, whether it's growth or decay. You're going to have to, for the main portion of this, be able to fill in a table. And this is where Desmos is going to be your best friend. So here's this. So I'm just going to need the calculator part here. So if I have, it says, what does the graph look like? So we're going to have to fill in this table. So this is the equation they give you. F of x, or like y, equals 2 to the x. You're going to take all of these values and plug them in for x into the exponent. So I take 2. And then for Desmos, you're going to press this right here. That raises it up to the exponent. And I'm going to plug in a -2. And when I plug in a -2, I get 0.25. And then instead of a -2, I'm going to go back over. I want a -1. I get a 0.5. Instead of a -1, I'm going to plug in a 0. Anything to the 0 power, remember, is 1. And then I want to plug in a 1, and I get a 2. Delete out the 1, put in a 2, I get a 4. Delete out the 2, put in a 3, I get an 8. So use Desmos to help you with that. Now, what I'm going to do, because I'm going to end up having to find out these 4 characteristics of my graph, but to make this easier on me, I'm going to actually graph these points. Once you have them graphed, it just makes things so much easier. For me, even though I teach this, it's so much easier for me. So I'm going to plot these points. So I go left 2, up 0.25. So just up a little bit. There's that point. -1, half, 0, 1, 1, 2, 2, 4, and 3, 8. So there's my points. Notice that these aren't lines, so this is kind of curved. So I always start from, I go here, and this is, you're gonna connect the dots, and it's just gonna continue up. Now here, this is where you're going to continue this to the left. You also are gonna see some that go to the right, but it's gonna get close to this x-axis. As you can see, it's like, it doesn't actually ever go negative for the y's. So that means don't cross that x-axis. If it doesn't go negative, don't go negative. It does level out a little bit. Do you remember when the governor was talking last spring about flattening the curve? This is what she means. She wants to go, like we had high COVID cases, and she wanted to flatten the curve. We wanted it to go down. So that's when we say flatten the curve, that's what we mean in terms of like exponential. And really that's what was happening last spring, is the cases were rising exponentially. So we don't want cases to go this way. We'd rather them go this way and flatten that curve out. And that's what here, it starts out flat, and then this one goes up. So you're probably gonna hear me talk a lot about COVID cases because that is the most common. Now we can refer to it for exponentials. So these are the 4 characteristics that you're going to have to identify today. Good news is domain, just like the domain on the last ones, your domain is always going to be -infinity to +infinity. That you should not have to think about. How far left does the graph go? We don't know. How far right? We don't know, because it goes to the right forever. Now for the range. Range, again, is how far down, comma, how far up. So my graph goes down to 0, but it never actually touches 0. So you're going to need to put a curved bracket. If it included the 0, if it actually touched 0, you would put the closed bracket, but it gets close to 0, doesn't actually touch 0, so we put the curved. And then how high up does it go? We don't know, so infinity. The y-intercept. The y-intercept is where your graph is crossing the y-axis. That is right here. This point right here, I go over 0, up 1, so 0, 1. And then the asymptote is going to be a y equals equation, and it's y equals, and this is my x-axis, so you're going to want to put x-axis, but x-axis is the y equals 0 line. Kind of like when we did the, what were they? Oh, the absolute values, and we did the horizontal asymptotes, and if it was on the y-axis, it was x equals 0. If it's on the x-axis, it's y equals 0. I know that's kind of weird. Bear with me on that one, but yes, I do know that's a little weird. Okay, let's look at one more for today. I do want to show you one that is decaying. So this problem right here, so I'm going to pull up my Desmos again. And again, all you're doing is plugging these values in for x. Now this one, because you do have a 1/3, you are going to get some junky numbers, so don't freak out. So I have a parenthesis, 1 divided by 3, go out of my parentheses, and then I need to raise that to the -2, and I get 9. And then instead of the -2, I'm going to plug in a 1, and I get 3. I promise you that the decimals are coming. And then instead of the -1, I plug in a 0, and I get a 1. Here come the decimals. I plug in a 1, and you get 0.3 repeating. Plug in a 2, 0.1 repeating. See how it's getting smaller and smaller and smaller? And then you plug in a 3, and you get 0.037 repeating. So there are my points. What I'm going to do is I'm going to plot these points to help me with all of my characteristics. So -2, 9, -1, 3, 0, 1, 1.3-ish, and you're just going to kind of sketch this. 2.1, 3, getting closer. So then when I draw my graph here, I'm getting really close to that x-axis again, but don't actually cross it. So there's what my graph looks like. So this graph from left to right is going down, and that's because this is less than 1. This is decay. So the domain, don't think about the domain. It's -infinity to +infinity. Range, how far down does your graph go? The lowest my graph goes, it looks like it gets really close to 0, but never does it. How high up does it go? Well, this has an arrow on it, so it goes up and up forever. Y-intercept is right here, over 0, up 1. And then the asymptote, it gets really close to the x-axis, which is y = 0. So today what you're going to do is you're going to be filling in tables, filling in domain, range, y-intercepts, and asymptotes. I would recommend, though, kind of sketching these graphs out to help you with those intercepts and those ranges. Any questions, we will be coming back to this tomorrow, but also don't hesitate to reach out.